Hello friends, today I will discuss the coherence in laser. When a laser beam is emitted from a source, there will be phase difference between the beams at different points. That is, it may be possible that there will be some time gap between the two atoms to come from upper energy level to lower energy level. Therefore, the term coherence refers to the degree of correlation between the phases. In other words, two or more light waves are said to be coherent if they bear a constant phase relation among themselves. Types of coherence. Coherence in laser can be classified into two ways. Temporal coherence. Now consider a light wave traveling along positive x-axis. Consider two different points A and B along the same wave plane, that is along the x-axis, like in this diagram. So suppose at point A, phi A is the phase of point A at any time and phi B is phase of point B at any time. Then phase difference between these 2 points is given by phi equals to phi A minus phi B. If phase difference is independent of time, then points A and B are said to exhibit temporal coherence or longitudinal coherence. So there are two things. That is, the phase difference should be independent of time, and these 2 points must lie on the axis parallel to the axis of propagation of the wave. Now, this is known as the temporal or longitudinal coherence. In other words, a beam of laser is said to exhibit temporal coherence if the phase difference of the waves crossing the 2 points lying on a plane parallel to the direction of the propagation of beam is independent of time. Second type of coherence is spatial coherence. Consider a light wave traveling along plus x-axis. Draw a line perpendicular to the direction of the beam. Consider two different points C and D on this line. You can see this thing in this diagram. So C and D, they are lying on a line perpendicular to the direction of the propagation. So if phi C is the phase of point C at any time and phi D is phase of point D at any time, the phase difference between them will be phi C minus phi D. Okay, phi C minus phi D. So if phi is independent of time, then points C and D are said to exhibit spatial coherence or transverse coherence or lateral coherence. In other words, a beam of laser is said to exhibit spatial coherence if the phase difference of the waves crossing the 2 points lying on a plane perpendicular to the direction of the propagation of the beam is independent of time. So the difference between spatial and temporal coherence means in the temporal coherence, the points lie along the axis. In temporal coherence, the points lie perpendicular to the axis of the propagation. I hope you have liked this article. So please, for further reference, please search our website venascience.com. Please subscribe to our channel, that is youtube.com user venascience. Thank you. Thanks a lot.